Welcome to another Chapter 6 video. This one's dealing with the normal approximation to the binomial. And we have to recall a little bit about the binomial. First of all, in a binomial, it is discrete, whereas the normal is continuous. So that's one of the differences and why it's only an approximation and not an exact value. The mean, mu, is n times p. The standard deviation is the square root of npq. These are necessary because this is what's required for a normal distribution. All of our other calculations, as you recall, use the mean and the standard deviation. So you'll have to find those. Requirements or conditions, and this is huge. You have to be able to do these, or this has to be there. NP has to be greater than or equal to 5. That's the mean. And NQ has to be greater than or equal to 5. If that doesn't happen, it will not meet the criteria and your approximation won't be valid. Second thing you have to do is correct for continuity. These are two steps that do not exist in a regular normal distribution problem. Those are the two parts that for this question would be counted more heavily. So looking at that correction for continuity, your question will be asked in the X binomial. That's where it's asked. It's answered using the X normal. So there are just a few different scenarios of types of questions. In the binomial, you could have, for example, the probability that an X value is less than, say, 50. If you look at the idea of a histogram with a binomial distribution, 50 being in the middle there, 49 and below would be that. The part that's shaded is halfway between 49 and 50. So in the normal probability area, we would be looking at the probability that X is less than 49.5. That's the correction for continuity, because its curve would come in more like this. You would lose some and gain some. So it's only going to be approximate, but you have to go in between. Another scenario is that it would be less than or equal to 50. With our same little sketch, $50 or less, while halfway in between would be less than or equal to 50.5. And remember, in a continuous, less than or equal to does not matter. We could do greater than 50. There's the 50. Greater is 51 and above, halfway between the 50 and the 51. And you could do greater than or equal to 50, which is like above, except the 50 is included. Halfway between the 49 and the 50. So the probability that x is greater than or equal to 49.5. And then the fifth type, the binomial does have a probability that x equals 50. In the normal approximation to that, that's between 49.5 write that neater, and 50.5. So that, to me, the sketching is a way to make sure I've got the right correction for continuity. There is a table in your textbook that helps, that is just a memorization technique for deciding whether it's less than or equal to, etc. So that's the correction for continuity. So in dealing with these, make sure you know your formulas, make sure you check your requirements, and make the correction for continuity.